So you could have marked your work. Everything wrong. Okay, let's look at it. It says, what is the maximum height that the object reach? Okay, so maximum height is there. Immediately if they say maximum height, in your head you must say, alright, for that 12.1 to be true, the final velocity is 0. Okay, and I'm going to tell the person, I'm going to look at from where the ball or the object or whatever is dropped until it reaches its maximum height. So that is the scenario I'm looking at. The initial velocity was 4.9. I don't have the time. I want to calculate the height, the displacement, and the acceleration is negative 9.8. Make sure you understand where I get the values from. Why do I have the values that I have? Why does it differ from yours? And if you have a question, you must ask. Yes?
Why is it negative?
What direction did we choose to be positive? Up. And which direction is a gravitational force? Sharp? Okay. So we need a formula independent of time, and I think it is this formula. Okay, so this is 0, this is 4.9, and you get y to be what, Princess? Yes.
And so can we call it gravitational acceleration?
Can we?
Can I call it gravitational acceleration?
Yes. That is exactly what it is. Yes, Princess? Yeah. It's not, it's 1.225. 1.225 meters. Okay, so what did we just calculate? We calculated how it went from there to there is 1.225 meters. But is that the entire height from the ground? No. So you're going to take this and you're going to add it to 44.1 meters. Okay, so you're going to say, right, so the height that it reaches, the maximum height, is 1.225 plus 44.1, and that gives you 45.33 meters. 2 marks. And then adding that, and that's 4 marks. And they love to ask this question. This question I took from an exam question paper. Okay. Yes.
How did you get 1.225?
Say again?
How did you get 1.225?
You took, I'm going to do it here on the right hand side, you took 4.9 squared. Okay. So that gives you 4.2. Okay. I said negative because I just took it to the other side. So I'm doing it from there.
Okay, I know what I meant.
Are you sure?
Yeah. I didn't, because I put the 4.9 with the 2. That's what I didn't say.
Ja. Wat's fout, Mama? Okay, quickly look. So you squared that, and then I took it to the other side to get that. Okay? And then, because they're separated by plus, so you can't add them together. And then you're going to divide. Alright. Then question 2.2, they ask, what is the velocity of the object when it reaches the ground? Yes, what's wrong? What is so wrong? You're not going to get 0, you're going to get 1 for the formula. Okay. Right. Then question 2.2. They ask, what is the velocity when the object reaches the ground? Now here you can look at two scenarios. 3 actually, but I think most of you thought 2. You can either look at the whole motion, the whole flight, or you can look from the maximum height until it reaches. Okay. Which one do you want to look at? The whole flight or from the maximum until it reaches? The whole flight. Okay, so that's what we're going to tell the person. Consider from the initial velocity until the ground or whatever. Okay, so my info table must fit with what I said there. Okay, yes. No, but like this chapter has so many memos that if the person needs to start to look for what did you do, they can easily just say, it looks like she... Bokang, in your bag. Put it off in your bag. Okay. So they can easily say, she tried something at the beginning that went with our first option in the memo. 1 mark for the formula, wrong the rest. Because you substituted different values from different scenarios. So they're not very kind with giving marks here. So that is why you want to tell the person, please go to this part of the memo. This is what I tried. And then they might look for where you did what. All right. Okay, so our initial velocity was 4.9. We want to determine the final velocity. Our time, we don't know. Our acceleration is gravitational acceleration, 9.8, negative 9.8, because we chose up to be positive. But ma'am, the object is now falling down. It's going down, so shouldn't it be plus? Shouldn't that be plus 9.8? Why not? We chose up to be positive. And if you did that at the beginning, you stick with it all through the question. You are not allowed to change. So even if the object is going down, that doesn't matter. I chose up to be positive, so it's negative 9.8. Always, always, always. Okay. And then the trick here is the displacement. Okay. I'm going to look. We looked at the whole flight there. So our displacement is from there directly down. So that is 44.1 meters. But in which direction is it going? Down. Which direction did I choose to be positive? Up. So it's going to be negative 44.1. Yes?
What's the difference between delta x and delta y?
Delta x is horizontal, delta y is vertical. Okay. Now we need a formula again, independent of time. It is this formula. Now, in the first lesson of this chapter, I said when you use this formula, you must be careful. Why must you be careful? Because there's a square root. And what is a square? What does a square do? It changes everything into positive. Okay? And when we need to do that, square root it, you cannot have a negative answer and square root it. So you must be very careful because sometimes we do need the negative because it's going in the negative direction. So we must be very sensitive when we use this formula. Okay, and then you square root the whole thing and you get, now I can't remember, 29.81. Okay, but, a big fat but. We looked at this motion. So when it's going down there, reaches the ground, it is going down. It's going in the negative direction. So our answer should actually have been negative. But due to the squares and the square root, it is not. Okay? So you must know, actually, this is downwards. So actually, when I use this next, my answer is negative 29.81. Yes?
Is it a must write?
No, I'm doing that for myself. That's fine, yeah. Okay, then question 12.3. They say, how long is the flight of the object? So again, we want from the start to the finish. So we're looking at the whole flight, or from start to finish. So we want the time. We have the initial velocity is 4.9. We have the acceleration is gravitational acceleration, negative 9.8. We just calculated the final velocity to be 29.81, but it's going down, so it's negative 29.81. Okay, and then we do have the displacement negative 44.1. So you could have used any formula because we have all the information. I'm going to use this one because it's the easiest one for me to use. And you get the time to be 3.54 seconds. Can time be negative? No. So if you do get a negative answer, you know somewhere you just have a direction wrong. Alright. Sharp. Okay, now I know there's more exercises in that little booklet, but I want to go to the question paper that we have in your exam. Okay, so I want us to go there, please. Okay, now the bell is not going to go immediately. So I want you to first do a question on your own, and I want you to ask me. So I'll be here for help, and I want you to ask.